My name is John McDonald, and I'm the founder and CEO of Threatrix. Threatrix is an application security company focused on helping our customers easily reduce the risk of using open source software and achieving both security and license compliance. Lately, we've had the pleasure of working with companies to help them find all of their occurrences of Log4j. It's been an area of significant research for our team, and we've learned a few things in the process. In our experience, there are three core detection cases or steps to detecting the presence of Log4j. Step one involves a port scanning solution to detect active running instances of Log4j. This step is relatively simple, very fast, and very accurate. These are the most common and concerning cases, or instances rather, that can be exploited by an attacker. Step two involves scanning your own proprietary software for instances of Log4j as they're used by your development team within your proprietary software. Seeing as open source software makes up more than 80% of proprietary software, and Apache Log4j is an open source component, it's very likely that your development team is using Log4j within your projects. This step involves detecting Log4j in all of the ways it's being used by your development team, which can be quite challenging, especially in legacy applications. Step three involves scanning all of the devices in your organization that might contain commercial software that was built using Log4j. If you perform step one, then these instances are likely dormant, but may be reactivated at any moment, putting you at risk. So the goal of this step is to determine exposure and create a remediation plan. In this video, I'm going to demonstrate the capabilities of our Log4j detection tool, which is able to detect occurrence of Log4j in steps 2 and 3 for cases that other tools will likely miss. First, a quick summary regarding areas of detection. For step 2, detecting open source in your projects, Threatrix detects Log4j in the following cases. Can detect it as a dependency from dependency managers. Now, this is where most other tools stop detecting, meaning they're potentially missing a lot, if not most, of the instance of Log4j. Threatrix can also detect open source as a standalone component downloaded in your project, as a forked Log4j project or Log4j source code included as source files, even snippets of Log4j source code within your projects. Threatrix can detect Log4j source code and embedded Log4j references when the file name is changed, and even if the file itself has been changed substantially, such as by changing the class name, method names, or variable names. We have spent years developing this proprietary technology. Recently, we've added a new detection capabilities to uncover occurrence of Log4j as they might exist on a device, such as a hard drive. Our customers are looking to remediate their risks associated with potentially dormant instances of Log4j that may be reactivated at any moment. This method of detection involves aggressively searching the device for occurrence of Log4j in all its potential forms. Threatrix can detect Log4j in more than 30 archive formats, including those you'd expect like jar, EAR, and WAR, but also numerous others like zip, tarball, and unexpected formats like RPMs, EXEs, or even CAB files. We extract all of these formats up to 10 levels deep to search for occurrence of Log4j. We can also detect archives even without a file extension. This is quite common for Docker images, which are created in tarball format, but the file name is just a hash of the image with no extension. These cases, again, will be missed by their tools. That, however, as we uncovered, wasn't enough. During our research, we recognized that simply matching archives in the traditional way with a hash of the file didn't uncover 82% of the occurrences. So 82% were missed using the hash only method. What we discovered is that oftentimes distributions of open source don't match the standard distributions. This can happen for a variety of technical reasons, but be aware that if your tool vendor is only matching by using archive, they're likely missing the vast majority of occurrences. Threatrix can detect even these undetectable archive occurrences of Log4j by using an advanced technique based on our proprietary technology that allows us to correctly match with unprecedented accuracy. We can find all Log4j occurrences with extremely high fidelity. What you're looking at here is a comparison of Threatrix detection capabilities to competing Log4j tools. Threatrix is able to detect Log4j in extreme cases, including nested archives, Uber and shaded jar cases, and even cases where the file names have changed or where the archives have been altered. So let's jump into a demonstration. Threatrix Threat Agent is a command line tool that's used by our customer to detect open source vulnerabilities and license infractions during build time. It can be integrated into our customer's build environment for automatic detection of all of the open source used by your developers to construct your projects. Threatrix reports vulnerabilities and license infractions to your development team with suggestions for remediation. The method of detection we referred to in step 2, project testing. Well, this is traditional. This is a traditional area of focus. We have modified the agent's capabilities to perform device scanning for the purpose of detecting Log4j on hard drives of devices like workstations, servers, VMs, or even Docker images. It can be installed easily using curl, npm, or Docker and easily scripted for deployments to hundreds or thousands of devices. Once it's installed, scanning devices with our agent can be accomplished with a single command, just basically pointed to a directory or device where you'd like to find Log4j. So in this demonstration, in this particular case, I'm actually scanning my workstation, and I'm just scanning the root folder of the workstation. So it's going to include all of the data on the entire drive. Now you can see here, my drive is, let's see, it is about 500 gig with about 296 gigabytes of actual data on the drive. And so if we jump over to the results, I've actually already performed a scan of this particular drive. We get some debug data, and then it lets us know what the progress is during scanning. In this particular case, we have about 16 million files, which included about 7,800 archives, and the scan was complete. If we scroll down to the bottom, it does give us a synopsis of all of the archives discovered, the numbers of those archives. And if we go to the bottom, it was about 410 seconds. So it's pretty fast. It scans, again, this scanned my entire hard drive looking for instances of open source embedded within archives. It's looking for Log4j. And it was able to scan my entire hard drive, about 500 gigabytes or 300 gigabytes of data in around 410 seconds. So while the summary report is helpful, it's relevant really only for the single device. And most of our customers want to see data across hundreds or thousands of devices. So this can obviously easily be accomplished in one of two ways. First, scan results across all devices are available in Threat Center, which is our dashboard. So let's go over there and take a look at that. So our Threat Center dashboard, what we're looking at here is actually our entity dashboard or teams dashboard. It allows you to aggregate data across multiple scans. So you could potentially have thousands or tens of thousands of scans within coupled within a single dashboard, and ultimately that data be wrapped up for you in the charts across the top. For device scanning, by default, the project name is essentially the host name of the device. You can provide your own project name, which can be anything that you feel useful, right? So it could be a server name, IP address. We can even assign a unique value. The one that we just scanned was our web server. We can assign, by default, we can assign a hash to the name, but it's more useful. Obviously, you have thousands or tens of thousands of devices. We can assign it actually the server name with IP address. So we click through to the results for this particular scan. Again, we get a summary of the results, including vulnerabilities, license risk, asset composition. Now, this is across all of the open source that we detected on that particular drive. And the most interesting part here, if we go to the assets tab, gives us a complete breakdown of those assets. So the asset tab gives us the capability to navigate through the discovered assets as they would appear on the device. So only folders that contain archives are actually included in the results. So effectively, all paths lead to an archive. So if we go down to our opt folder, where we typically have some commercial software installed, go to opt, we can go to Apache Cassandra, down in the lib directory. We can see that, we have a couple of jars from the Apache Commons lib directory, and several more jars, of course, in here. So this gives us an idea of what kind of results we can see from just a random, commercial application installed and drive. We're going into those directories, recursing those directories, looking for all archives that could potentially contain log4j. We're opening those up 10 levels deep, and we're extracting that and looking for instances of log4j using our proprietary technology. You can also, from this screen, of course, we can filter these based on just open source components. So we can say, look, we just want to see open source components here. And we can see that we found 4,116 open source components in the results. These are displayed essentially to indicate the association of these hashes. So what we can do here is if we search, again, we can just search specifically for log4j. And we can find all instances of log4j that we discovered within the platform. And actually, what's really interesting here is we search for log4j. Now we actually find log4j embedded in other archives. So here's an example of Flowable Engine. This is a zip file. Inside the Flowable Engine, we have org.flowable designer libs. So this is proprietary. This is a proprietary jar from a commercial application, and embedded in there, lo and behold, we actually found log4j 1.2.17, which is actually a pretty old version of log4j within this platform. We can detect all versions of log4j within the platform. You can see here in this Threatrix master zip, we actually found another newer version of log4j 2.16 and 2.17 as examples. So while the assets tab shows the assets as they exist on the device, the components tab will essentially show us all of the detected open source components with their associated vulnerabilities and licenses. And again, from here, we can filter by just log4j, search for log4j instances. And of course, we can filter these by just log4j instances with known vulnerabilities, which makes it really, really simple to find just the log4j. So an important note here, while Threatrix is a software as a service solution, we're a cloud provider, none of the contents of any of the files being scanned are sent into the cloud. In fact, you can verify what's being sent into the cloud by viewing our scan request that's being sent into the cloud. It's an option with Threat Agent. You simply pass an option in, an argument, the command line, it'll dump that scan request out to the drive. You could take a look at it yourself. So I mentioned there were two ways to view the data. The first way is, of course, through our platform. I want to quickly mention here before we move on, you can see all the vulnerabilities and licenses associated with all of the open source we detected, specifically for, this is used typically for, as I mentioned before, step 2, where we integrate directly into your DevOps pipeline and can determine all the vulnerabilities and licenses for the open source components that your developers are using to construct your applications. So the second way to view this data is, of course, through our API. So Threatrix has a GraphQL API, making it a perfect solution to consume large amounts of data. And you can select essentially exactly which field that you'd like to see. So this is an example of GraphQL query. It's basically pulling back component data from our system. And you can see here, we're basically naming the fields that we want to bring back if you're not familiar with GraphQL. So that way we can select only the fields of interest to us to, of course, expedite the query and reduce network traffic as well. It's very helpful. So all this data can be exported. All the data we're just looking at can be exported and extracted into whatever platform you see fit to consume this information. So in short, Threatrix is the ideal solution for the detection of log4j. whether it's within your software development projects or within your DevOps lifecycle, or essentially across thousands of devices where you might find Log4j. So with that, I'm going to wrap up. I hope this was useful for you. If you feel that we can help you with the challenges associated with detecting Log4j, please reach out to us. And thanks for watching.